special cases factoring. So I'm going to teach you special cases factoring by you discovering it. So here we go. This is multiplying this thing times that thing, okay? So it starts off real simple here. X times x is x squared, okay? Again, I am not teaching you this. I'm trying to repeatedly show you something, and whoever you're watching this video, try and look to see if you see where I'm going. If you pick up, if you figure out the pattern is what I'm trying to show you here, okay? So x times x, x squared. X times -1 is negative x, followed immediately by 1 times x, which is plus x. Ooh, okay? And then 1 times -1 is -1. Cool. What interesting thing happens that is kind of nice?
They cancel out.
Ooh, cancel out. The x's cancel out. Yes, the middle guys in the middle there, minus x plus x, these cancel out. Cool. So I have x squared minus 1. Got it. Okay, now, I didn't just teach you something. I'm trying to point out interesting things to see if you can piece it together. So let's see if you can maybe piece it together after this one. X times x, x squared. X times -5 is -5x, followed immediately by positive 5 times x, which is plus 5x. Ooh, more canceling. 5 times -5 is -25. Got it. What interesting thing happens here? These middle terms cancel out. Now, here's my question. Why are they canceling out? What about the original problem is causing this to happen every time? What do you notice about the original question? The x's?
I mean, they're the same, just one's causing.
I would say they're definitely not the same.
Oh, well, not the same, but just opposite.
Opposite is what they are, okay? They're exactly opposite. I know that you see, okay, they are both 5s,
So,
but it's a 5 and a -5, right? So opposites, that's the hugest thing. Hugest, does that work? Probably not. See,
possibly.
Okay, this is now, I want you to do this problem using no math whatsoever. Don't use any math, just look at it here. What do you think? Skip this whole step right here where we did all this, because the end answer here is x squared minus 25, right? Because the middle terms canceled out. What would this answer be right to the answer? Don't do any work. This is I'm going against everything math teachers before me have said.
-36.
It would be x, it would what?
X squared minus
X
36.
squared, that makes sense.
Yeah. Minus
Minus, I think I heard you say it,
36.
36. Correct, that's the answer.
Nice.
And it took 1 second to do that, right? Because you understand a pattern, because you understand what's going on, okay? There's more to this though. Why could we go here? What did I not write down? What step did I step? What step did I skip?
Yeah. The multiplying.
X times x was x squared. That's fine, that's right there. X times -6x followed by a plus 6x. Then these cancel out and you're left with the minus 36. See what I'm saying? That middle step is what canceled out. Because these signs are opposite, okay? So now I'm gonna throw one more little curveball at you and see if you can get this going here. X, what am I doing? Oh yeah, x minus 7 and x plus 7. What would that answer be?
It would be x squared.
X squared
Plus.
plus?
Hold on, doing that.
Interesting. And as you're watching the video, if you think something's different than what you're saying, just hold on to that too.
Isn't it still -49?
Ooh, -49. Yes. Because it's always going to be that sign at the end there. It's always going to be this thing at the very, very end there, this minusing situation.
Why?
Why is that always going to be negative?
Because they're opposite.
Because they're opposite. Why do I know they have to be opposite? What happens in the middle? Those canceling out. How does it cancel out? What do the signs have to be for it to cancel out?
Opposite.
Opposite, right? That's the whole. You see the big chain reaction picture, and these things that you can just if I know this, then it only can be this, and you can jump straight to the answer, right? Because they are opposites is why the middle term cancels. Whatever that middle term would have been, that's why it cancels. And because they're opposites, that's why it has to be a minus sign right there. Okay. In fact, I really like that you said plus, because that is guaranteed. That's an answer option on a test. They're like, haha, let's see if they remember the sign. Got them. Test makers are evil. People who make tests, which I guess is me sometimes.
You're evil.
Evil, right? Because that's a very popular option because of what we just talked about, okay? But why another reason? This is so important. That's why I want to hammer this in real quick. Why is this also impossible? For me to multiply two 7s together, what would their signs have to be?
The same.
Both positive or
Both negative.
both negative. And would they cancel out if that happened?
No.
You see what I'm saying? Okay, that's the big picture. All right, so, do I want to talk about that? In fact, yes, I will. Yes, I will talk about that. Okay, so real quick, this is a bonus content right here. Bonus content right here. I can tell you right now, instantly, with almost no math needed, that's going to be x squared plus 14x plus 49. Do you see how do you maybe understand why I got this so quickly?
Because it's plus 7.
Okay. When the 7s were opposite signs, what happened? What? When the 7s were opposite signs,
They canceled.
they canceled out. Okay, cool. Are they opposite signs now?
No.
No. So instead of a 7 and a -7, it's a 7 and a 7, which is just 14, right?
Yes.
And then 7 times 7 is 49, and that's your answer. Okay?
Yes.
Which is basically me doing x times x is x squared, x times 7 is plus 7x, 7 times x is another plus 7x. So instead of canceling, they doubled, if you want to think of it like that, like again, right? And then 7 times 7 is 49, right? Which gets you the combining like terms and not canceling this time, they doubled, I guess. Okay, anyway, okay, cool. So, erasing that. Now, so far, I have not taught you a single thing about this unit.
Wow.
You're welcome. But I have taught you the backwards version of this unit. So now we're going to go forwards and see if you can understand what the question is. If this is now the question, right? Originally I was giving you this as the question, right? These little bundles, x minus 6, x plus 6, right? Now I'm giving you this and I'm saying factor it, which is what you've been doing in factor. So, okay, cool. Factor it. I'm going to take this, right? I got my x's. What do you think the answer is? X minus 5, x plus 5. And the opposite whole thing, right? Or x minus 5, x plus, as long as they're opposites, I don't care. So I got my 5 and my 5, and it's a plus minus. Great. Or minus plus, whatever. Opposites is the biggest picture, okay? Cool. Now let's do this one. What we got? Minus 10 plus 10. Yeah, minus 10 plus 10. Right? Got it. Yes, yes, yes. That's what's happening here, okay? Now, I'm going to say something a little weird now. This is called special cases factoring,
Okay.
but it's also the exact same as factoring, okay? I've never seen any math teacher teach this part, and I think it's important to show you how it's the same thing as factoring. It's just, you get cool shortcuts in your head because you know this stuff's happening because of not canceling out stuff, okay? So, what this really is the same thing as saying, it's the same thing, well, that's an awful arrow. There we go. That's the same thing as saying x squared. How many x's are there?
2.
Ooh. That's an x squared, right? So that's not an x.
Just one.
Right? So how many x's are there? Here. How many x's
Oh, none.
are in? None. Yeah, there's no x's there, okay? I know there's an x squared, and I don't want you to blow your minds because an x and x squared are not the same thing. X and x cubed, not the same thing. X to the 4th, oh, this is definitely getting not much, yeah, not the same thing. All right, there are no x's there, right? Minus 25, right? So does this look like a normal factoring situation right now? Like we've been doing? X squared, x, number, A, B, C, okay, cool. Now I'm gonna ask you the same math riddle from before. And I don't want this to blow your mind, stay with me. What two numbers add to get nothing and multiply to get 25? See what I'm saying?
Oh.
What two numbers? You already know the answer. You already know the answer. You did it right here. Remember that? Okay. So what two numbers add to get nothing, which is weird to think about, but it'll make sense here in a second, and multiply to get negative 25? A 5 and a negative 5. This means negative in sign language.
Really?
I'm just kidding. There's a sign language interpreter. The sign language in this whole thing. Is that a word? Sign languaging? It is now. So negative 5 is when I hold it upside down. Okay, anyway, 5 minus 5, if I add these two together, they are 0. And if I multiply them together, they are this. So it's the same thing that's happening, okay? It's just, do I need to write this in the middle of everything? No, and that's why it looks like that, right? That's why it looks like these two things here. So in your head, you should see this, but you should really know that is a canceling in the middle. Something canceled in the middle, which means that it was the same number that got canceled in the middle to be no middle. See what I'm saying? Okay, the middle term is gone. That's the biggest picture I'm trying to paint you. Now, let's make this a little bit more difficult, and we're done.
Love that.
This right here. I want you to be able to do this, and you should be able to do this and any harder problems like this using all of the same logic and knowledge we just have talked about right now. So, first thing I would write down, here and here, was the first thing I would write down.
The X's.
I mean, sure, you can write down the x's, sure, because the x squared, but what?
25 on the outside.
5. Ooh. Oh, I see what you're saying. I see what you're saying. I'll talk to you about that. I see where you're going with that. But stay with me on this. I'll do a different example. It's not this. I put the 5s right here. Do you see why there's 5s right there?
Because if you multiply.
I'm splitting it into 2 different parts right here, right? Okay. So this goes there and this goes there. The 100 goes there. The 100 goes there. I'm keeping perfect squares is what's going on here. Okay. So I have the 25. 25 breaks up into 5 and 5, and then I have opposite signs. And then I have 10, and I have 10. Do you see what the big picture is there?
Yeah.
That's right, that's the big picture I'm going with. Okay. The next level realization that somebody just had was that these have a 5 in common. And I can factor out a 5. I see what you're saying with that. I don't want to worry about that right now, because yes, you can take out a 5. These have a 5 in common, you can take out a 5.
I was saying
Okay.
just like divide the whole thing by 25. And
Yeah. And then you'd have the 25 on the outside, and okay. But I'm more so trying to show this type of special cases factoring for the sake of this example. And then we can do the same thing here. So I got 6. In fact, we'll do this right here. We'll do 64, 29. Shoot, we'll just do 25 because we can. Okay. Cool. And yeah. All right. So maybe the last problem, I want to do one more just to clarify what just happened right there. But right here. I'm going to break these apart, and this might make sense as to the big picture. This is the hardest type of example you'll see. One piece at a time. What are each piece going to be whenever you separate them? So what would go here and here?
5x.
5, 5 and 5, because the 25 is, x to the 5th, x to the 5th. Cool. X to the 5th. Time out right there. Do you see how the 25 and the 10 are different here? You see how we have, both 5s? What am I doing to the 25? You might not realize what you're doing. Square rooting.
Oh,
Square root. The square root of 25 is 5. 5 squared is 25. The square root of 25 is 5. See what I'm saying? Squared versus square rooting. But with the exponents here, what are you doing with the exponents? Well, you're basically subtracting and just cutting them in half. Evenly cutting them in half through addition and subtraction type stuff, So you are evenly splitting them apart here so that when I combine them together, 5x times 5x is, 5x to the 5th times 5x to the 5th is 25, and then you add exponents, right? Okay, cool. So my signs are going to be opposite. Always, I don't care which one you write first, okay? I'm a positive person, so I usually write the positive one first. And then 64.
8.
Here's the biggest thing that people do wrong, is they'll say 32 and 32.
I said
8 is correct.
Yeah.
Why do you think people do 32 though?
Because they were splitting.
Like, half it. They usually don't get this one wrong, but then when they do this and they half it, then they get into halving mode. And they're like, half it. Whoa, careful. You're dealing with an actual number now. So it's an 8 and an 8. Because 8 times 8 is 64. You gotta make sure it comes all the way back around, okay? And then the last thing, they each have y's. We have 3 y's and 3 y's. Cool, okay? And that's it from easiest backwards to the hardest one forwards.
Nice.
Special cases factoring.